So the basic premise to trying to figure out obesity from my perspective is not to begin with the patient who has obesity and diabetes, but rather to go into nature, because nature can teach us a lot. And in nature, obesity is actually an advantage at times. At times, it's critical for survival. So if we can understand how animals stimulate and develop obesity, then we might be able to get some clues to what might be driving obesity for us. So for animals in the wild, it's all about survival. They need to have enough food and water, to provide the calories and nutrients that they need. And if there's no food or water, it's a real disaster. And some animals will actually store food in little caches back in their dens, so that when they're in trouble, they can go back there. Or during the winter, the little chipmunk can wake up and eat some of the food that's next to it. And we know the story of Aesop's fables, where the ant was storing food all summer long, and the grasshopper was hopping around and playing. And then in the fall, when it starts getting cold and the food disappeared, the grasshopper had to go to the ant and say, "Hey, can I get some food from you?" And the ant said, "No, you didn't take care of yourself." So animals actually do know, when there's, during winter, there's not going to be so much food. And so a number of species will actually purposely gain fat as a way to store energy. The classic are the hibernating animals, like the bear. And the bear will maintain a regular weight throughout summer. If it eats too much one day, it doesn't matter, it'll eat less the next day. It kind of maintains a normal weight. But beginning about a month, or probably about 8 weeks before it hibernates, it will suddenly change its behavior. And it will get extremely hungry. It will start foraging for food. It will eat enormous amounts of food. It will gain 8 to 10 pounds a day. It will become insulin resistant. It will get fatty liver. And it gets actually all of the features of metabolic syndrome. And in fact, that's also true for the hibernating ground squirrel. All these animals, when they are preparing for hibernation, they actually develop the metabolic syndrome, something that we think of as pathophysiologic, as a disease process. But for these animals, it's actually the normal thing. It's actually it shouldn't be called metabolic syndrome. It probably should be called fat storage syndrome. So the big question is not the question of why they hibernate and how they hibernate, usually what people talk about, but actually a more interesting question is what triggers the weight gain? Why is it that these animals, which normally regulate their weight beautifully, suddenly lose this weight regulation and gain so much weight and fat? What's the process? What activates it? Let's be detectives. And it turns out that for many species, it's fruit. And the animals in the fall, when the fruit ripens, the sugar content goes up in the fruit. And these, like the bear, will eat so much of it that it actually seems to trigger the weight gain. And it's not, I know what you're thinking, natural fruits are healthy, right? And they are for us because we're eating small amounts. These guys are eating like 10,000 berries in 24 hours. It's a very different level of sugar intake, okay? So these guys are eating a lot of fruit. And so let's talk about fruit and sugar. The main sugar in fruit is called fructose. And glucose is the other main simple sugar, and that's, of course, what's in our blood, and it's the main carbohydrate we use. In addition, there's table sugar, or sucrose, which is one glucose and one fructose bound together. And then we have high fructose corn syrup, which has a mixture of fructose and glucose put together. And fructose is the sweeter of the two sugars. And by combining the two, like in high fructose corn syrup, it makes the food taste particularly good. And in fact, most drinks, soft drinks and stuff, will have a higher fructose to glucose content because of the sweetness and the fact that people like that. So when we were wanted to study this, what we did was we put fructose in the drinking water, and we had 2 bottles, so they could drink regular water or fructose water. And we let our laboratory mice decide which one they wanted to drink from, and they would dramatically, of course, prefer to drink from the fructose bottle. And the ones that got those 2 bottles, the ones that would drink so much fructose that they became extremely fat. They became insulin resistant. They got fatty liver. They got all the features of metabolic syndrome. And the control mice, who just had 2 bottles of water and regular food, you can see what happened to them here in this picture. So basically we could show that fructose could induce metabolic syndrome. Now, it was really interesting. The first 2 weeks that they're given fructose, the first 3 weeks, they will actually reduce the chow they eat to maintain balance. So initially, they try to maintain their energy balance. But when you keep giving them this fructose sugar, suddenly, around the 2nd week, they lose control of their appetite, and they keep eating, and they'll eat more chow and drink more sugar water. And so it accelerates. So that's sort of interesting that it disrupted this normal weight regulation. So the question is, how does the fructose actually do this? And it turns out that it's an energy balance thing. It's an energy problem. And it relates to the mitochondria, just as you heard earlier. The mitochondria are the main little organelles in our cells that make energy. Now, normally, when we eat food or calories, that energy is used to make ATP. ATP is what the mitochondria make. The mitochondria churn out this ATP. It's the energy that we use to do everything. And in the cells, when you eat a nutrient, they try to maintain the energy levels high. The ATP levels are high. And if there's any extra food, any extra energy that comes in, once the ATP levels are full, then that gets stored as fat. Okay, and so that's how it works. When you eat, normally, if you're in balance and you have good energy, your mitochondria are working beautifully. They produce the ATP. You keep the ATP high, and that's how it works. Fructose is the only nutrient that does a trick. And the trick it does is it stuns the mitochondria. It's an actual mitochondrial poison. We actually identified the mechanism. And what it does is it suppresses the mitochondria so that they make less ATP. And so they don't actually fill the whole tank. The ATP levels are kept at a low level, about anywhere from 10 to 30% lower than normal. And when that happens, at the same time, it blocks the conversion of fat to ATP. It blocks what we call fatty acid oxidation. And so it blocks the ability to break the fat down to make the ATP. So the ATP levels stay low. When you eat, the energy gets shunted. It's an energy balance equation. The energy gets shunted to the fat, which is a stored energy, and not to the active energy. It's a brilliant system. And eventually you cap up, the ATP levels come up, but when it's done, you've eaten a lot more food than you should for trying to stay in balance. And so you end up accumulating fat. It's brilliant. So the biochemistry of it, I'm just going to show this one slide. It's all driven by an enzyme called KHK, fructokinase. The hell of a killer enzyme. This KHK enzyme metabolizes fructose. It's the first enzyme in that pathway. And from that, you generate energy and all the things like all nutrients do. But there's a side chain. There's a side reaction that occurs when this happens. And that is that KHK burns some ATP to make energy. So all foods require some energy to be consumed to make energy. But this one's like an unregulated train. It's like a runaway train. It just absolutely drops that ATP level rapidly. So there's a fall in ATP, and that accumulates this substance called AMP. And then that activates an enzyme that removes the AMP. Now, AMP is normally used to replenish the ATP. So we're removing the ability to remake the ATP. And at the same time, it generates a substance called uric acid, which is the cause of gout. But when it goes up inside the cell, it's the mitochondrial poison. And it basically activates the system that suppresses the mitochondria, blocks the ATP production, as well as the ability to recover ATP. So you have a low ATP state. So there's actually 5 steps in this process. It's amazing. It just keeps the ATP level down. And everyone with obesity and diabetes, the vast majority of people who have obesity, diabetes, metabolic syndrome, fatty liver, all these diseases have low ATP levels. This, as far as I'm aware, this is the only nutrient that lowers ATP. Alcohol does too, actually. So when we studied this, we found that it activated a whole syndrome, a syndrome that included foraging, hunger, thirst. It stimulates the accumulation of fat and glycogen and eating increased amounts of food. It induces insulin resistance and systemic inflammation and even raises blood pressure. And it's all to help you survive. This was all meant to be a good thing. The insulin resistance that it induces leads to less glucose being used in the muscle, which is an advantage because it provides more glucose for the brain. And some areas of the brain do not require insulin, not all, but some areas do not require insulin, and so it helps maintain glucose levels to the brain. It reduces the amount of energy that's expended in the muscle, so it reduces energy metabolism. So it reduces resting energy, but the foraging, when you're foraging, it actually does not reduce that. So you can walk and run and look for the food, but when you're not doing that, you're going to rest very well. You're going to just kind of like be like a couch potato. And in fact,